Question number 9 is menthol, the strong smelling substance in many cough drops, is a compound of carbon, hydrogen, and oxygen. When 0.1595 grams of menthol was burned in a combustion apparatus, 0.449 grams of carbon dioxide and 0.184 grams of water is formed. What is menthol's molecular formula if the molar mass of menthol is 156.3 grams per mole? So in this type of situation, kasi gumamit tayo ng combustion apparatus, it will be safe to assume that we have complete combustion. Isa din na clue na complete combustion siya is nag-release siya ng carbon dioxide. Kasi kung incomplete combustion siya, carbon monoxide yung product niya. Okay, so we have whatever proportion ng carbon, hydrogen, and oxygen dyan, nag-produce ng carbon dioxide and water. Anong gagawin natin? Since we're already given the masses of carbon dioxide and H2O, kailangan natin i-determine yung amount of carbon in terms of moles. So that's 0.449 grams of carbon dioxide. I-convert natin into moles of carbon. So the molar mass of carbon dioxide is 44.01. That's for every 1 mole of carbon dioxide. And then per 1 mole of carbon dioxide, you have 1 mole of carbon. So you calculate that, you have 0.0102 moles of carbon. And then for moles of hydrogen, you have 0.184 grams of H2O times the molar mass, which is 18.016 grams per 1 mole of hydrogen times 1 mole of water pala. And then for every 1 mole of water, you will have 2 moles of hydrogen kasi merong dalawa doon sa chemical formula natin. And that will give you 0.0204 moles of hydrogen. Now we have carbon, we have hydrogen. Now we're looking for oxygen. Pero hindi natin pwedeng gamitin na 0.449 lang. Hindi pwedeng 0.184 lang because carbon dioxide has oxygen. Water has oxygen. So merong component sila na oxygen. So anong gagawin natin? We convert these values into grams. Tapos, we will subtract these resulting values from 0.1595 grams ng menthol. Okay? Now let's do that. Convert mole carbon into grams oxygen. Give me one moment. Into grams oxygen. So that's going to be 1 mole of carbon is equal to 12.01 grams of carbon. That's going to be 0.1225 grams of carbon. So in this amount, in this amount, 0.1225 grams yung carbon. And then for hydrogen, you have 0.0206 grams of hydrogen. So you have these two values. Now, minus natin siya. Dito 0.1595 minus 0.1225 yung sa grams carbon minus 0.0206 grams of hydrogen. That gives you 0.01638 grams of oxygen. So alam na natin ngayon how much oxygen there was in 0.1595 grams of menthol. Following that, we will now be able to calculate for the number of moles of oxygen. The molar mass of an oxygen atom is 16.00 grams per 1 mole of oxygen. That gives you 0.001024 moles of oxygen. Klarong-klaro, di ba? Oxygen yung mas maliit na number of moles. Kasi dito, for carbon, you have 0.01020. And then for oxygen, you have 0.0204. For oxygen, you have 0.001024. So we'll divide that with the smallest molar value at 0.01020 all over 0.01024. That will give you 10 or around 10 anyway. Tapos ma-round up mo lang siya kasi ang lapit-lapit sa 10. That's 9.9 something. And then hydrogen, you have 0.0204 all over 0.001024. Now, if carbon was 10, hydrogen will be 20 since times 2. Times 2 siya ng molar amount ng carbon. And then, of course, oxygen will be divided by itself. So thus, you'll have 1. Now, your EF, or your empirical formula, will now be C10. Oops. C10H20O. Now let's move on to the next question. What is menthol's molecular formula given the molar mass? Given the molar mass. Let's clear the page. Oops. Anong kailangan natin? Diba? First, we need the empirical formula weight. So that would be 12.01 grams per mole. Kasi diba yung empirical formula natin, C10H20O. So times 10 plus 20 times 1.008 plus 16. And that will give you 156.26 grams per mole. Compare that with the given molar mass. Diba? To get the whole number multiplier, you just get the given molar mass, divide that with the EFW, 156.26. In this case, the answer will be very close to 1. So that's 1.00 something. So we can just round it off to 1. Meaning, yung molecular formula natin will be the same as our empirical formula, which is C10H20O. Okay? So let's proceed to number 10. Now, number 10 is balancing na. So we're required to balance the equation of the following reactions. We've got letter A, that's scandium plus water is scandium hydroxide, Sc, capital S, OH sub 3. Now, what I do, like the sample packet that I gave you, is to Sc is to tally. So H and then O. Ito yung mga elements in performing in the reaction. On the left side, you have 2 Sc. On the right side, isa. And then your hydrogen, dalawa. Here you have 1 times 3 equal to 3. And then for oxygen, you have 3 plus 1. On this side, you only have 3. So what do we do with these values? It becomes clear now. We multiply this side with 2. So lagyan natin ang 2 dyan. And then, since it's a stoichiometric coefficient, maapektuhan din tong dalawang to. That means this would be multiplied with 2 as well. Ngayon, meron na tayong balanced na Sc. However, our hydrogen is very lacking. 2 times 3 is equal to 6. Diba dito? So here, to make it 6, you have to multiply it by 3. So, i-multiply din dito ng 3. Madadamay yung oxygen. So, multiply din ng 3. Now, you have balanced na hydrogen and then 3 plus 3 times 1 is equal to 6. Balance na siya kasi 2 times 3 is equal to 6 din. So, balance na. So, your final answer for letter A should be Sc2O3 plus 3 H2O gives you 2 ScOH3. Okay? And then letter B, you have calcium phosphate plus silicon dioxide plus carbon gives you phosphorus plus calcium silicate plus carbon monoxide. So let's do our tally. Calcium, phosphorus, silicon, carbon, oxygen. On the left side, you have 3 carbons. You have 2 phosphorus, isang silicon, isang carbon, and then 2 times 4, that's 8 plus 2. So that's 8 plus 2 oxygen. On the right side, you have 4 na phosphorus, isang calcium, isang silicon, tapos isang carbon, and then you have 3 plus 1 oxygen. Now, it may look very magulo. It may look very messy, but if you continue on practicing, this kind of layout can make sense to you. Now, since we have 3 calcium atoms on the left side, so in the right side, kailangan natin i-multiply ng 3. Change ako ng color. Kailangan natin multiply ng 3. So that's 3. Now, madadamay yung ibang elements in that compound. So, ito mamumultiply din ng 3. Ito din mamumultiply ng 3. Okay? Since now, nagbago yung number of silicon natin, naging 3 times 1. So, that's equal to 3. Yung sa left, kailangan din na multiply natin ng 3. And, maapektuhan yung isang oxygen, yung O2. So, ito yung mamumultiply ng 3 din. Right? So, balance na yung calcium, balance na yung silicon. Now, our oxygen is currently 6 plus 8. So, that's 14. And then on the right side, you have 10. Ano pa yung hindi natin na-balance? Ano pa yung hindi natin na-balance? Di pa natin na-balance yung phosphorus. Na yung phosphorus, P4 dito, dito dalawa lang. So now, we multiply this by 2, maapektuhan yung calcium na na-balance na natin kanina. So now, we have to start all over again. So let's try to start over. Now, for balancing, do not be sad if you have to start all over again. That's a thing that happens. Kasi trial and error yung balancing natin, especially if you're out of practice. Okay, so let's start again. That's calcium phosphate plus SiO2 plus calcium. So P4 plus calcium silicate plus carbon monoxide. So that's, start na tayo ngayon sa P4 kasi sa P4 tayo sumabit kanina, di ba? Then calcium, then Si, carbon, and oxygen. So 4, dito 2, and then 3, and then 1, and then 1, and then 8 plus 2. Dito naman 1, 1, 1, and then 3 plus 1. So now let's multiply this by 2. Oops, 2. So na-multiply din yung calcium and na-multiply din yung oxygen. So now we have 4 phosphorus. So balanced na. And then yung calcium natin, we now have 6. So we multiply this by 6. Right? Kasi 1 times 6 is equal to 6. Equivalent to 2 times 3. So nadama yung ibang nasa compound. And now, 1 times 6 yung silicon natin, we have to multiply this by 6 as well. So we have 6 SiO2, and then ito din, 6. Right? Okay. Now let's look at our oxygen. Sa oxygen natin, we have, that's 16, and this is 12. Right? And then here you have 9 plus 1. So 10. Right? So we have to find a way to balance these numbers. So that's 16 plus 12, that's 28. And then 9 plus 1, the, I'm sorry, this is not 9, this is 18 plus 1 is equal to 19. So para maging 28 siya, kailangan natin itong i-multiply by 10 para maging 28, right? Because this is 18, then this is 10, as ito, this is 16, and then ito, this is 12. So that's 28 on both sides na. So multiply yan by 10. So 10 yung dito. That means yung carbon natin para mabalance, multiply din natin ng 10. And there we go. Balance na. 6 on the left side, 6 the right, 6, 6, 10, 10, 28, 28. Now we're done. So our balanced equation would be 2Ca3PO4 2 plus 6 SiO2 plus 10 carbon gives you P4 plus calcium silicate, 6 calcium silicate plus 10 carbon monoxide. So that's our final balanced equation. Okay, now let's speed up and go to number 11. For number 11, we're being asked to convert the following word chemical equations into symbols, so balanced chemical equations. So letter A. So what we need here is our skills on sa ionic nomenclature. If you haven't had that sa lab ninyo, do not worry, you'll be having an activity involving naming compounds, naming chemical formulas, and like ionic acids and molecular substances. So for now, just watch what I do. For these types of things, you have to make sure that you know kung saan yung reactants and yung products. So you have to understand the statement. Now, the statement is, when lead nitrate solution is added to potassium iodide solution, solid iodide forms, lead iodide forms, and potassium nitrate solution remains. Now, these words are our clues. Since lead nitrate is added to potassium iodide solution, we know now na sila yung starting natin. Sila yung mga reactants. So lead nitrate is Pb, NO3, 2. You'll know why doon sa lab ninyo. Or if you already know, then that's good. K plus potassium iodide is Ki. It gives you, diba? It forms lead iodide, Pb, I2 plus potassium nitrate. So that's KNO3. Now we just have to make sure that it's balanced. So we need a 2 here sa nitrate kasi may subscript tayo na 2. And then 2 dito sa K. KI kasi 2 here and then dalawang I. So now we have our balanced equation. Now for letter B, you have nitrogen dioxide bubbled into water, meaning pinareact mo sa water. It gives you a solution of nitric acid and gaseous nitrogen monoxide. There we go. It's quite easy, diba? So you have dalawang hydrogen. So now you have 3 nitrogen on the right side. So you had 3 and here. And then afterwards, let's look at the oxygen. So you have 6 oxygens left plus 1. So that's 7. Now you also have 2 times 3 plus 1 is equal to 7. So balanced na pala. Okay, so that's our final equation for letter B. Now let's go to number 12. For number 12, you have potassium nitrate decomposes on heating, producing potassium oxide and gaseous nitrogen and oxygen. So binigyan na tayo ng unbalanced chemical equation. Now to produce 56.6 kilograms of oxygen, how many moles of KNO3 must be heated? Okay, where do we start? If you need a reaction, if a reaction has occurred, then of course you will need the balanced chemical equation. So i-balance natin. You have dalawang K, so you put 2 here. Now you have 6 oxygen, so you need to put 3 on your oxygen right here. And then dalawa yung N, dalawang N. Balanced na ba? Or not? So what do we do? Let's do it all over again. Wait. Oh, there we go. So KNO3, K2O plus N2 plus O2. Now watch what I'm gonna do here, huh? Let's start with what we did kanina, dalawang K. So balance na yung K, balance na yung N, tagdadalawa. Now on this side here, we have 6 na KNO, na oxygen. And then on this side here, we have 3. So kailangan natin somehow 5 plus 1. Kasi ayaw na nating galawin yung K2. Kasi kung galawin natin yung K2, magagalaw din yung K dito sa left, di ba? So what we need to do is to change this somehow para magkaroon tayo ng 5. How do we do that? Now this is a trick that you do with diatomic na molecules. You can use halves. So what I need is 5 over 2 oxygen. Diba? 2 times 5, that's 10. Divided by 2 is 5. And that's the exact number of oxygen that we need. So if we have 5 right here plus 1, we have a total of 6. So balance na siya dito kasi 6 yung nasa left. Now, the last thing you need to do is multiply all sides of the chemical equation by 2. Kasi bawal sa final balanced equation na mayroong fraction. So even if you use fraction at first, you have to make sure na wala ka ng denominator pagdating sa final na values. So you'll have 4 KNO3 kasi na times 2, 2 K2O plus 2, 2 N2 and 5O2. So yan yung final balanced equation natin. Now we can proceed with the actual calculation. Hinahanap is moles KNO3. Binigyan tayo 56.6 kilograms of oxygen. And when we say oxygen, di ba, non-metals ito siya, oxygen is a diatomic molecule. So um, it appears, it manifests as O2, hindi O. O2 dapat. Kasi oxygen gas yan. And then we first convert kilograms into grams to make it easier for us. And then convert grams O2 into moles of O2. So that's 16 times 2. Kasi nga O2. Diba? O is 16. Since O2, you'll have 16 times 2 per mole of O2 times 5 moles of O2 per 4 moles of KNO3. Saan yan ang galing? It came from here. 5 moles of O2 sa reaction is equivalent to 4 moles of KNO3. This is why it's very important that you have the correct values from your balanced chemical equation. Kasi if mali yung mga stoichiometric coefficients mo, then you will have the wrong molar ratio. So pag-calculate mo, mali na yung values na makukuha mo. If you put that into the calculator, you'll have 415 moles of KNO3. So that's your final value. Okay, now let's go to number 13. Methanol, CH3OH, is produced from the reaction of carbon monoxide and hydrogen gas. Binigyan tayo ng unbalanced equation. Now, the question is, how many moles of methanol can be produced when 4.5 moles of carbon monoxide reacts with 7.2 moles of H2O? Sa mga ganitong problems, pag binigyan ka ng mga starting quantities ng mga reactants, whether grams of both reactants or masses of both reactants or the number of moles of both reactants, this is a signal that you're dealing with a limiting reagent problem. So when it comes to limiting reagent problems, you have to determine first saan yung limiting reagent before mo ma-answer yung actual question. To do that, we would first need, as always, our unbalanced chemical equation. We need to balance that one. So CO plus H2, we have CH3OH. Gagawin natin just to put 2 here. And that's it. Kasi 4 na H. Isang O, isang carbon. Next, we determine the limiting reagent. To do that, kailangan nating magkaroon ng isang quantity na pwede nating ma-compare yung dalawang reactants. In this case, i-compare natin sila by converting the reactants into moles of the product. Since moles methanol din naman yung hinahanap natin, di ba? So we convert, we get moles CH3OH from carbon monoxide. So that will be 4.5 moles of carbon monoxide. Sa reaction, you have 1 mole of carbon monoxide is equal to 1 mole of CH3OH. That means you will have 4.5 moles of CH3OH. Now, when you convert H2 into CH3OH, you'll have 7.2 moles of H2. And then sa reaction, 2 moles of H2 yung kailangan natin to produce 1 mole of CH3OH. Right? So now you have 7.2 divided by 2, that's 3.6 moles of CH3OH. Now you can see kung saan yung mas maliit na na-produce na moles of CH3OH, di ba? Kung saan yung mas maliit, kung anong reactant yung na-produce niya na quantity, that will be your limiting reagent. In this case, it's H2O. So your limiting reagent or LR, sinushortcut ko na lang, would be H2. Now, you use this value. If grams yung hinahanap, i-convert mo yun ng grams. But since moles na yung hinahanap, this is your final answer. 3.6 moles of methanol is produced with 4.5 moles of carbon monoxide and 7.2 moles of H2. Okay, so we're up with the last two problems. So for number 14, for number 14, you have metals react with oxygen gas to produce metal oxide. For example, you have calcium. If react mo sa oxygen gas, you'll have calcium oxide. You wish to calculate in terms of mass in grams the calcium oxide that can be prepared from 4.20 grams of calcium and 2.80 grams of oxygen. So again, we're given the masses, the starting quantities of our reactants, meaning we have to determine the limiting reagent first before doing whatever is required doon sa problem. And then afterwards, kung saan yung limiting reagent, kung ilan yung na-produce niya na moles of the product, i-convert natin into grams of calcium oxide. Okay, so let's start. Yung equation natin, is it balanced? No. So we have 2 oxygen. So lagyan natin ng 2 here. Since apektuhan din calcium natin, so you put 2 here. So yan na yung balance equation natin. Now let's determine the limiting reactant next. So you have moles of calcium oxide from calcium. So you have 4.20 grams of calcium. Convert natin into moles of calcium. So that's 39.10 grams per 1 mole of calcium. Convert natin into moles of calcium oxide. So 2 moles, based on our equation, 2 moles of calcium is equivalent to 2 moles of calcium oxide. So now you'll have 4.20 divided by 39.10. So that's 0.2148 moles of calcium oxide. Now let's proceed with the moles of calcium oxide produced from oxygen. So you start with 2.80 grams of oxygen gas. Convert natin into moles of oxygen gas. So that's 32.00 grams per 1 mole of oxygen gas. Then based sa reaction natin, gumagamit tayo ng 1 mole of oxygen gas to produce 2 moles of calcium oxide. So if you put that into the calculator, that will be 2.80 times 2 divided by 32. So the final answer will be 0.175 moles of calcium oxide. Klarong-klaro na kung saan yung limiting reactant natin. So oxygen gas is our limiting reactant. Now we use this amount to calculate for the required quantity, which is mass in terms of grams of calcium oxide produced. So 0.175 moles of calcium oxide times 1 mole of calcium oxide is equivalent to 55.1 grams of calcium oxide. That's the molar mass. Now, although I'm writing here 0.175, it would be better if kaya nyong mag-start from here. Yung walang na round off ha, to avoid rounding off errors. Anyway, if you calculate that, you should have 9.64 grams of calcium oxide. So now we are solving faster because we already know the steps to convert grams into moles, to convert moles into grams, vice versa, to use molar ratio, and to balance chemical equations. Now let's go to number 15, which involves reaction yield or percent yield. Now we have 56.6 grams of calcium and 30.5 grams of nitrogen gas. So nag-react sila. And it has 93.0% yield. Ano yung mass in terms of grams ng calcium nitride na na-form? Now, hindi tayo binigyan ng reaction. So this is a test of how well you could make reactions from the word or the description given. Sinabi dito, calcium and nitrogen gas undergo a reaction. That means, yung dalawa, sila yung reactants natin. So you have calcium plus nitrogen gas, diatomic molecule in nitrogen. Okay? Kaya N2. Now, for those who are not aware, we have 7 diatomic molecules. That's hydrogen, H2, oxygen, O2, nitrogen, N2, chlorine, Cl2, fluorine, F2, bromine, Br2, and iodine, I2. So if you use that in calculations na wala silang kasama sa compound, if they're by themselves, walang kabonding, then they will be manifesting as diatomic molecules, gaseous diatomic molecules. Now, sinabi, ano yung mass ng calcium nitride na nag-form? So, calcium nitride is Ca3N2. Okay? Now, the formula for percent, like I said earlier, that's gonna be component over total. So, in this case, for percent yield, you have the actual yield all over the theoretical yield times 100. Now, wait. We have to balance pa pala our chemical equation. So, you have tatlong calcium, so you put 3. Then you already have N2. So, no other problems. So, ito na balance na natin yung chemical equation. Now, you have to calculate the theoretical yield. Where do you get the theoretical yield? Yan yung yield galing sa purong calculations lang. So what we are doing so far, yan yung mga yield na theoretical. So if nothing goes wrong, if everything is perfect in this world, you will have that exact amount in the lab when you're experimenting. However, humans are full of flaws. The world is not perfect. So yung actual yield natin when performing that specific reaction will always be lower than our theoretical yield. Unless na lang perfect ka, then magkakaroon ka ng 100% na yield. But that very rarely happens. So our formula is actual yield over theoretical yield times 100. Now to calculate for theoretical yield, or Ty, or just T, you have to, surprise, this is a limiting reagent or limiting reactant problem. How did I know that? We are given the masses of our reactants. So, kailangan natin i-compare muna yung mga reactants natin to know which one is the limiting reactant. So, let's first solve for the moles of calcium nitride na galing sa calcium. So, that's 56.6 grams of calcium times 39.10 grams per 1 mole of calcium times, based on our reaction, kailangan natin ng 3 moles of calcium to produce 1 mole of calcium nitride. That will give you 0.4825 moles of calcium nitride. And then we'll calculate the moles of calcium nitride produced from nitrogen gas. So that's 30.5 grams of N2 times, that's 14.01 times 2 kasi N2 nga. So 28.02 grams per 1 mole of N2. And then based on our balanced chemical equation, 1 mole of N2 is equivalent to 1 mole of calcium nitride. Calculating that, you will get 1.0885 moles of calcium nitride. Okay? Then, We now know kung saan yung limiting reagent natin. Ang layo ng dalawa, di ba? Isa 0.4, isa 1.08. So our limiting reactant is calcium. Hindi pwedeng yung limiting reactant is calcium nitride ha. Kasi calcium nitride is a product. So hindi talaga siya pwedeng maging limiting reactant. Kasi hindi nga siya reactant. Okay? Now we use this calculated value from our limiting reactant to solve for the grams of calcium nitride. So ito yung theoretical na yield. So when everything's perfect, you will have 0.4825 moles of Ca3N2 times, kailangan natin yung molar mass ng Ca3N2. Yung molar mass is already solved earlier. That's 145.32 kasi 3 times 39.10 plus 2 times 14.01. 1 mole of Ca3 and 2. And that will give you 70.120 grams of Ca3 and 2. So we have this as our theoretical yield. Oops, I need space. Let me erase a couple of lines here. Okay. So let's solve for, bakit ko in-erase to? Susulat ko lang ulit. Ay, nako. Times 100. Now let's solve for A. Kasi meron nating percent yield, which is 93%. We just recently solved our theoretical yield. So now A na lang yung kulang. To solve for A, we have percent yield all over 100 times your theoretical yield. So that's 93% over 100% times 70.120 grams of Ca3 and 2. That would give you 65.2 grams of Ca3 and 2. So that's your actual yield. 93% of your theoretical yield will be your actual yield. And that's it. So that was question number 15. So now we're done with our sample exercises. If there's a bit of confusion, you can rewatch these videos, and still if you cannot get it, if there are some points that would need clarification, feel free to email me or send a message through the group chat. Okay? Do not be shy, because if you're shy, then you will not have your answer. You will be left wondering forever. So ask. Okay? I think that's it for today. I'll be ending the video here. Thank you and goodbye.